All right, and our final example. So not exactly a cheery one, but this gives a kind of an idea of what's involved when forensic investigators look at incidents such as bomb explosions, how they recreate the situation. So a bomb is sitting at rest. It breaks into three pieces when it's set off. It then gives us information about each of the pieces. We want to know what was the original mass of the bomb. So the before situation, simply just a dot. There is no momentum, so to speak. The after, though, we have three pieces breaking off. Piece one heads north 25 degrees east. So 25 degrees is not the angle I want to use. I want to use 65 degrees, and it was 3.4 meters per second. Piece two is 0.75. Velocity east 78 degrees south, 78 degrees, and it's traveling at, what was it, 9.8. And finally, piece three has a speed of 5.3 meters per second. What is the mass of the original bomb? So that last mass there, the last piece, doesn't give me a direction. North, and then piece three has a speed. What's the mass of the original bomb? So that's all the information I have. I have no idea. Now I know that my assumption here was, in order for this to be zero, piece three has to be facing somewhere in this direction, and I'm going to take a stab in the dark and say it's over in this direction, mainly because that 9.8 is such a big number that I'm thinking it's in that quadrant. So what does that mean? Creating my formula, total momentum equals the sum of the three momentums afterwards. So I want to know, I got to find out information about that third bomb, or the third value. So PT minus P1 minus P2 is going to equal the momentum of the third object. Now the nice thing here, when the initial situation is that first PT, or the initial momentum, is actually zero, so we don't actually have to consider it when we do our calculation here. So we are going to have negative momentum 1 minus momentum 2 is going to equal the momentum of the third piece. So that being said, what I'm going to do here, that first vector, momentum for number 1, both the x and y component are going to be positive, so I'm already going to incorporate that negative in. So I'm going to distribute that negative and make both components negative, so it's taken care of. So I'm going to have negative, and the first mass is 3.2, velocity is 3.4, cos 65, and that is in the I direction, minus, again, I'm distributing that negative in so I don't have to worry about it later on, or don't forget about it. 3.2, 3.4, sine 65J. That second piece then, it had a mass of 0.75, so 0.75, 9.8, cos 78, and minus, because it's in the lower quadrant, 0.75 again, 9.8, oops, cos sine 78, sorry. That's in the J. Now we just go ahead and we can do the calculations. There's enough information there for us. So there is the momentum of the third piece of this bomb. So from that we can find the total momentum. So we're finding the magnitude of it then. So the 6.12 squared negative plus negative 2.7 squared equals, go ahead and do that calculation, and we end up with a magnitude of 6.7 kilogram meters per second. So there's the magnitude of the third piece. I want to find that angle. Actually, we don't really need it. We need to know the angles. We're looking for a mass. So in this case, I wouldn't really require theta because I'm looking for the momentum of the third piece. I know it's mass times its velocity. So I know the momentum was 6.7. I don't know the mass. I do know the velocity of the third piece was 5.3. So from that, 6.7 divided by the 5.3, I find that I have, let's call it 1.3 kilograms is the mass of the third bomb piece. So therefore, our mass total is going to equal the 1.3 from the third piece, 0.75 from the second, and 3.2 from the first. And when we add those three pieces up, or three components up, we get a total of 5.25 kilograms approximately. So therefore, bomb mass is 5.25 kgs. There we go. So you can see how vectors play an important role in momentum when we get into the two-dimensional stuff. So here's the homework questions that are assigned. Page 220, 47 to 56. If you run into difficulty or problems, make sure you ask. If there's anything in the note that you're not sure of, please make sure you ask tomorrow in class for clarification. And like I said, got to be careful with our vectors here, with signs and everything. So there will be some frustration that does exist. But anyhow, good luck and we'll see you tomorrow.